Hey QE Decoders, this is Michael, and you're seeing me in reverse orientation. Actually, this is normal orientation because I'm pre-recording. I'm not going to be able to make the stream when you watch this video, but I wanted to give you a quick update because last week Jan pointed out a really important error that it had made in the queuing mechanism inside of Janaga.net. So I fixed it. I want to show you how it works. Let's take a look. I have here the Blog Maui application, and it is showing all of the blogs that I currently have in the replicator. This one up here, Hello World. Let's go ahead and click into that one. It brings us to the blog page. And now, of course, this is where we would, this is the post page. This is where we would, create content for the post, check on the comments, whatever. But for right now, it's got a mechanism for us to edit the post title. So let's change it from, whoa, goodness. All right. There's a nice little crash. Maybe? Was that a crash? No, it's still running. What did I hit? I hit Shift Home. Okay, I guess Home is the home button. Okay, don't do that. How would one select if they're using the mobile application? They would just long press. Anyway, that's not the thing to show. The thing to show is I can change the title. Let's change the title to Fixing the Queue. All right, so the title is changed. Oh, you can tab. Oh, okay. So we go back and we see Fixing the Queue is the new name. So added that feature so that I can show what happens when you create a new fact, because editing a mutable property is creating a new fact. So let's suppose that we were disconnected from the network when we're trying to do all this stuff. So let me switch to airplane mode, which messes with the debugger over here, so hopefully that will not interfere too much. But now I'm going to come back in here. I'm just going to hit refresh, and let's see what happens. It switches to yellow. So this is a little status indicator. I'm just showing you the status rather than binding to a different view that shows a green, yellow, or red indicator. But so it's now in the yellow status, which means that we had trouble reading data. So this is saying what you're looking at is not the most recent data, but at least you haven't lost anything. So it's just yellow. If I were to change this to, and I lost data, then go back, then I can see it's now switched to red. This should have updated. Okay. I'm collecting the bugs. There's another one to take a look at. So that should have notified the observer in that view model and changed the title of that post. So we've got a new title on the post, and now it's changed to red. This is telling us that we have queued up a fact and we were not able to send it to the replicator. So that means we are in danger of losing data. If we don't connect our phone to the network at some point in the future, then nobody will ever know about these facts that we created here. So we are getting that queuing behavior. Let's suppose I were to kill my application, which, interesting, the debugger was still connected, even though I... And then, let's go... Wait a minute, where is it? There it is. Right here, and let's start Blog Maui again. We can't start it from the debugger because we're in airplane mode. So, you can see that it has launched. I can see it still says Fixing the Queue and I lost data, which means that it is loading the local data. it says that the status is yellow because it wasn't able to refresh this page, but it just shows us what is currently saved there. If I hit refresh, let's see, it should have tried to do a push on that queue. So I would expect it to actually go to red in this case. It's like, nope, still red. There's still some data here that is not saved remotely. Okay, so still got some work to do on that. But the interesting thing is that we are showing the local data. We are working in a disconnected application. So let me come back here, and now we reestablish our connection. And now if I were to refresh, then it turns green, and it stays green. So it's able to save the data, it's able to refresh the data, so it's pushing, it's pulling, and everything is great. So others using this same replicator should see that new title, Fixing the Queue and I Lost Data. So that is the experience that we have so far. Still a few kinks to work out. But let me show you, first of all, remind you what the problem was that Jan found, and then show you how I fixed it. So to do that, I'm going to switch over to the Janaka.net source code. So we are here inside of the Fact Manager. Just to show what the code used to look like, let me go back to before I merged this pull request. Let's go back to right here. I'll create a little branch right here that I will call in the past. Okay, so in the past, we were doing a save to the store, notifying any local observers. That should refresh that other page that has your title on it. And then we are calling save on the on the network manager. The network manager, in turn, is adding those new facts to a queue. So the problem is, if you manage to save a fact to the store, but something goes wrong. In fact, something could very well go wrong here if you notify a view model and then that view model throws an exception. You're right out of here. So things could go wrong. So it's entirely possible to have saved a fact to the store, but not put it into the queue, and then it will never get sent. You will see that fact locally, but nobody else will ever hear about it. That's a big problem. So I fixed that big problem. Let's go back to git checkout minus, switch back to the previous branch, and this is what save does now. Let's go back to the fact manager, save. So we save it to the store, we notify our observables, and then we run this background task that saves it to the network manager. Hold on a minute. It looks like you're doing exactly the same thing as you were before. Saving it to the store and then saving it to the manager, network manager. What's the difference? The difference is the network manager is not taking the facts that were added as a parameter. Instead, it is loading all of those facts from the store in terms of its queue. So how did they get into the queue? I'm not saving them to the queue inside of the fact manager, the network manager. I'm actually saving them to the queue all in one shot, kind of by side effect right here in this SQLite store. And that's because when I save them to the queue, they get a brand new fact ID You can't even see it inside of the insert statement here. We're inserting into fact because it's an auto-incrementing fact ID, which I talk about in the book, why you shouldn't rely upon auto-incrementing IDs outside of your database. But inside of your database, they are sequential. And so you can use them to keep track of how far into a sequential stream you have read. That's known as a bookmark. Right here where I get the queue in the SQLite store, what I'm doing is I am getting a bookmark from this brand new table called QBookmark. There's another table already in the local database just called bookmark, and that's the bookmark from the replicator's feeds. So there's a feed hash that is the key to that bookmark table. So each feed has its own separate bookmark. The client is keeping track of the bookmarks on read, and similarly, the client is keeping track of its own local bookmark on write. So when I insert, I get brand new fact IDs that are greater than the bookmark. So now when I get the queue, hello, Mr. Biscuits. When I get the queue, I'm getting all of the facts with an ID greater than this last fact ID that I read from the bookmark. So in addition to getting those facts, we are also unioning in the ancestors of those facts. So we are getting a complete graph doing the transitive closure in order to get all of the facts from the ones that we just created and their predecessors. That's very important, as I discovered last night, when doing the save. Save requires a complete graph. We're not going to make any assumptions about what facts the server already knows about. So we insert. That automatically puts it into the queue because it's got a greater fact ID than the bookmark, and then we load all the facts from that particular bookmark forward. Then in the network manager, we go ahead and save those to the network, so that sends them all. And if we get back success, then we set the queue bookmark to the next bookmark. Whatever is the last ID right here, the max fact ID from the database. That's our next bookmark. So next time we get the queue, we're going to get all the facts beyond that. Nice, simple solution. And it actually rhymes with the read solution. We use bookmarks on read, we use bookmarks on write. I don't know why this didn't occur to me earlier. It's a great solution to the problem. So with that, we have all of our facts queued up and sent to the server. Now, there are a few other changes that I made that I think are pretty interesting. So let me walk through some of those. So you will see that, let's see, yeah, right. Actually, that's just a quick fail, or not fail, but exit early optimization if we don't have any facts in the queue. This right here, this is an interesting change. So the problem was that that when the user interacts with the application, say they change the title of a post, then the application is going to want to await the saving of that information. Suppose it wasn't just the edit experience that we had here, just this little editor here, but let's suppose instead it was a modal, and they type in the information and they push the button. You don't want to dismiss the modal, you just want it to pause until the data is actually saved. So what does it mean to be actually saved? When you have a persistent storage mechanism, like SQLite, then actually saved means saved to the store. When you don't have a persistent storage mechanism, like the memory storage provider, then actually saved means sent to the upstream replicator. So you save it to the store, and then if your store is persistent, then you start saving in the background. But if your store is not persistent, go ahead and save now and await that. So this gives you the right experience based on how you've configured your application. Get it into the store and let the user keep going, or actually have the user wait for that network communication. Depends on whether they are persistent or transient. So if they're transient, we want to run that in the background, and we've got this this neat little mechanism here to use a task handle. Add that task handle to a collection of background task handles. Then the background task itself will remove that handle from that collection. The reason that we have that collection of pending tasks is that now you can unload a Janaga client. And when you unload the Janaga client, it just awaits all of the pending tasks. That is very important for unit testing, as I discovered the night before last. So, 4 days ago. I discovered it 4 days ago. So, that is the set of changes that I made to the queue in order to correct the problem that Jan noticed, and then also to make sure that I get back to the user as soon as I possibly can if you've got a persistent mechanism. So now the last thing that I think will be kind of interesting is, what does this edit experience look like in the code? So this is simulating a mutable property, but of course Janaga is based on immutability, so you can't actually mutate anything. So we have the mutable property pattern. I've talked about that a few times already. It's in the book. So I'll give you a quick overview of it again, but that's not the really interesting part. The really interesting part is that the user is interacting with this text right now, but this text is backed by an observer. So if a new fact arrives that would change this text, then that would ordinarily mean that we want to update the user interface. But in this case, since the user has clicked in and they've given focus to this this little edit control, then the user does not want something else changing that text. They want it to be frozen for that time. And so I did a little dance inside of the view model in order to make that all work. So I'll show you what that is, and then at some point we'll abstract that so that you've got a nice little set of tools in the library. So all of that happened right here inside of the post view model. So we've got this observable property title that we data bind. Let me go ahead and show you the data binding, just in case XAML is something. Whoop, that's the post list. We want the post page. Here's the post page XAML. Nice and simple. We've got an entry, which is the MAUI, or I think this comes from Xamarin Forms, way of talking about a single line edit control. So we're binding to the title, and we're using two-way binding. So that means when title changes, we want to know about it, and then when the user changes the title, we want to set that property. So two-way data binding on title. In addition to that, you can see right here we are doing title focused and title unfocused. And so title focused, does F12 work? Yeah, it does. Okay, cool. So title focused is calling begin edit title in the view model, and unfocused end edit title in the view model. So what those are doing is those are doing that little dance, kind of switching the mode from normally the observer controls the title, but when you've got focus, the user controls the title. And then you lose focus, go back to the observer. Right here's the observer. Let's see how the observer gets set up. Right here, apply query attributes. That's basically the on appearing when you've got parameters. And so in this case, we are using the post as a parameter. So getting that through the navigation system, now we've got the actual post fact. Okay, so now we are loading the information, setting up that observer. Here's our specification. Given that post, give me all the titles in that post where there are no next titles. There are no next titles. So if there is a next title, that means this one's been superseded. So we're just getting the most recent titles. So this is the read part of the mutable property pattern. You'll always have this prior collection that points back to the prior versions of that mutable property. So here's the title of that post, and then these are the ones that this version just superseded, the immediate predecessors. So now if we don't have any successors, then we are the most recent version, and that's what we're getting. This gives us the most recent versions, the most recent titles for that post. So now we do a watch on that client for the titles of that post. And when we get a post title, we're going to do two things with it. We are going to, if we are not editing the title, we are going to change the title property so that it shows up on the user interface. But whether we're editing the title or not, we are also going to keep track of the titles in a immutable list. So this is my immutable list of all of my post titles. What I mean by all of my post titles is these are the leaves of the graph. So if there are no conflicts, then there's just going to be one leaf. It's just going to be a nice straight line, or maybe it'll fork but then come back together, and you'll just have one leaf. But if there have been concurrent edits in the past, then you will get multiple titles. So this is just going to get one of those to show on the user interface, but this is going to collect all of the candidates. Now, when this title is no longer a candidate, so when it's been removed, then we remove it from the title's immutable collection. How is it removed? It's removed when we create a new title that supersedes it, because now that next one exists that has this in its prior collection, and so it no longer matches this where clause, and it is no longer part of the titles of this post. So this lambda is called when we add it, and then this lambda is called when we remove that, the same thing. So remove it here, add it there. Cool. So now we've got an immutable collection of all of the candidate titles. And we are updating the title property as long as the user's not editing. What happens when they start to edit? So here we begin editing the title. So we're going to set editing title to true. That I'm sure you could predict. But then here, we're going to take a copy of this immutable collection, and that's going to be called the frozen titles. So now this is the list of candidate titles at the time they started editing. That's very important. Now when they end edit title, so they're done editing, now we're going to check a few things. So first of all, just make sure that we actually have a post, that we came through the right code so that post is set, that we actually have the frozen titles collection, so we actually came through this line of code here. All right, all of that's good. Now, here's the interesting bit. So, let's kind of think backwards on this one. If the frozen titles count is equal to 1 and the one and only value is equal to the title property as typed in, then there's nothing to do. That means that there is no conflict and the value is the title as the user entered. Could be that they just tapped in, tapped back out. Could be they tapped in, edited, undid their edit, and then tabbed out. But if either one of those things is false, so if you have any number other than one prior title, or the one that you do have is just a different value, in either one of those cases, it's time to update. So you create a new post title fact, you've got your new value, and you've got all of your prior candidates, all of the leaves at the time they started editing. And those are the prior titles for that post. Then you null that back out, you go back to not editing, and they're back to the observer being in control of the title property. So it's very important, as I have said a couple of times now, that this is the set of post titles at the time they started editing. So if a new fact arrives while the user is editing, not only do we want that new fact to not interrupt the user, but we also want to make sure that their edits are done concurrently with that new fact. So when they are finished, there's a concurrent edit. There are two candidates now. There's the one they just input, and there's this new one that they didn't know about when they were typing in their title. So something happening while the user is editing is just like something happening while the user is offline. They don't know about it, so it shouldn't clobber their work. They shouldn't clobber it. So you end up with concurrent edits, multiple leaves of the graph, and then no data is lost. So at this, with this bit of code here, we're not giving the user any indication that there are multiple titles. We don't have any property that indicates, oh, there was a concurrent edit. And then furthermore, these are the possible candidates. So that might be some useful user interface to explore. How are we going to do that for this example? How are we going to recommend that other people do it? But for right now, we've got this pattern working inside of Blog Maui so that we can edit a mutable property. Once all the dust settles on this pattern and it's all ironed out, then I will take as much of this as I can and I will package it up in some reusable fashion. That's kind of what I'm doing over here with this little folder. If I go to this Janaga Maui folder right here, there's already an authentication folder that's got some reusable stuff like the authentication token, the OAuth client, and then we've also got our configuration extensions so that we can add all of this stuff as a configuration to our IOC container. So that's where I'm basically collecting stuff that's going to go into the Janaga.Maui package. So I've already given it that namespace. It's already there. I can just pop it out of here, put it into its own build at some point later. So the support for mutable properties is going to end up in there, most likely. But that's what I wanted to show you. I wanted to show you that that we have a way to store facts while you're offline So we can say, and I did not lose yeah, 2 O's. I did not lose data. No, 1 O. I don't know. It's like, I don't know, I read or something. But I did not lose data. Woohoo! Yeah, see, it worked that time. Okay, but now it's red. That's red because I have data locally that is not on the server. But that's okay, because I did not lose data. No. Oh, other way, that way. Let's start it again. And you can see I did not lose data. Yeah, I really want that to say red. And if I were to come over here, let's just try this out real quick, see if this is going to work. And I'm going to read the blog posts. I get the fixing the queue and I lost data. That's because I'm disconnected. Now let's go ahead and connect. Switch back. Refresh. And I did not lose data because it was queued on the device and then it was sent to the replicator when I was back online. Stored locally, kept safe. And the user is notified of the status of that. So thank you very much for tuning in for this update to the Janaga client using SQLite for its local storage. And I look forward to seeing you next week. Let's see what awesome things we can build together.